All right, Ted, do you want to give a quick introduction and then kick us off?
Yeah. So hey everybody, thanks for joining. My name is Ted M. Young, and I've been doing XP since '99. When I first heard Martin Fowler talk about it, I was part of the Bay XP group that is unfortunately no longer in existence. Having moved to Silicon Valley and living in the Silicon Valley since '99, it's been very strange how XP startups seem to feel like it's not compatible, and I completely disagree. I've also been doing Java forever, pretty much as long as one could be doing Java and didn't work for Sun. And so this talk and the code examples that I'm going to show are Java code, but the concepts aren't only applicable to Java. They're not only applicable to languages that have static typing. So, sorry, I just saw Mike's message. I'm not sure what's going on there.
I only hear you, Ted. So I don't know if
great.
that's something else.
Just wanted a confirmation that it wasn't on my end.
Yeah, I'll make sure everybody's muted.
Yeah. I titled this talk, and I'd like to think about it as the emphasis on more testable code. We'll look at hexagonal architecture. That's one of the things that I've really gotten into over the past 5-7 years. But I come from the point of view of having worked on both small projects and large projects in companies like anywhere from eBay and Google to Apple and to Guidewire Software and elsewhere where I do training and coaching. And so I see a lot of difficulty in writing testable code. And so sort of my mission in life these days is helping people write more testable code and or refactor to more testable code. And I very much believe in refactoring. And that's as a way of making your code easier to work with. So I have a lot to say about this, so I can't possibly squeeze it all in to this presentation. There's a lot of nuance and a lot of depth, and a lot of things to explore. And so I'll do my small plug for this. Actually, is extracted from a course that I have, refactoring to hexagonal architecture. If you go to r2ha.com, I'm going to reopen sales for that. They've been closed for a while. I'm going to reopen sales for over the weekend, and you'll get the discount that everybody else got back in August. All right, ask questions as you need. Right, we're not a huge group, so would really, if you've got a question, throw it into chat. I will certainly notice it, or somebody will ping me in if there's a burning question. And so what I want to start with is sort of, what are tests, right? I mean, what I find really interesting is we have lots of discussions about things, and sometimes we think we're talking about the same thing when we're not. So I'm going to give you sort of the way I think about this. And to me, sort of what are tests is basically they're isolated, automatic, concise, self-verifying, precise, predictable, and written by developers, right? These are the tests that I care about because I am a developer, and I coach developers and I work with developers. And so I care about the tests written by developers. Ideally, in my opinion, I think if you write them first, it's great. So TDD, I'm a huge advocate for, but we don't always have the opportunity to do that. We're not always in code bases that are have been started out that way or amenable to that. But these are the things that I think about in tests, right? So isolated, I want them to be not only executable in isolation. I want to be able to run one test here, one test there, preferably all the tests, and they don't bother each other, but also from a readability and understandability standpoint. And of course, automatic, and I don't want manual stuff. Concise, so that they're expressive and saying just what the test is about. and not a lot of noise. And Java is a language that is known for its verbosity. And so there are refactoring ways that we can do that and make it more concise. Self-verifying, right? That just means we've got asserts precise, meaning that we don't get a whole bunch of failures, that they help us diagnose when something goes wrong. Predictable, right? It's no point in having tests that are flaky. I've worked on systems where we had annotations to say this test is flaky, and it's like, that's just wrong. Just make it not flaky. And part of the predictability is control over things that we don't have direct control over, and we'll see that. So of course, written by developers. Now, a lot of times people talk about two different kinds of tests: unit tests and integration tests. And one of the things that I've been doing is training myself to use neither one of these terms. So for better or for worse, and mostly for worse, these terms I don't find helpful anymore. If they ever were, maybe they were. And the reason why is I don't care. I actually don't care about, is it unit, is it integration? What does that mean? What I care about is how easy are they to write and how fast do they run? And all those other attributes that I just mentioned. So I'll talk about what I've replaced that with in a second. But I'd like to hear from you, like, why is writing tests so hard? Why do we avoid it? Why do we like take so much and struggle with it? Curious what you think.
I'd say dependencies. Specifically thinking of things that are dependent on databases, certain data coming through.
Yeah, dependencies, definitely.
Some toolings and frameworks actively feel like they are fighting you in order to test something. Having things like private constructors, and even for things like value objects or something, that you can't create or build one of those to use in your own test, and you just want to beat your head against the wall.
Yep. Any other thoughts?
I guess pressure, right? Whether it's actual or perceived sometimes.
Yeah, there's definitely the human aspect, and schedule and pressure and all those. But you know, if tests were like easy to write and encouraged, we probably wouldn't feel that pressure. But that's a whole separate talk. So to me, what I observed and experienced is there's sort of the internal problems that the classes are poorly organized, or whatever boundary mechanism you're using, they're poorly organized, and that's a problem. Or classes directly access IO, and I'm going to have a specific definition of what I mean by IO. Yes, exactly. Single responsibility principle I find is a great ideal. I don't find it very prescriptive. So one thing that you'll find is I like to have things that are very prescriptive, that tell me what to do. Because if it's just me, I can do anything. I've been doing this for 30 plus years. I think I'm a pretty darn good designer. I don't need structure because I can naturally create it and refactor my way. But you know, not everybody has 30 plus experiences in specific environments that lead you to being a good designer, especially working with lots of different people with lots of different levels of experience. I like to be more prescriptive, and we'll see that's one of the things I like about Hexagonal. So in terms of poorly organized, often what I see, especially on object-oriented languages, is way too much state in a class. So you want to instantiate it and then get it to a state where you can write the setup part or the arrange or whatever you want to call it. And it's like, oh my God, I have to load like 20 lines of code just to get into the state where I can test it, where it's right where I want it to be. Then I want to do that one action and then verify that it worked. And or it has too many responsibilities. And these are very tightly related. I have a whole separate talk about that, so I'm not going to go much further. That's not a problem we're going to solve here. The problem we are going to solve is about IO. And so for IO, I mean infrastructure. and whatever you want to call that, databases, external services, sort of the things we think about the context, the environmental runtime context of our system. Hardware is also something that I consider under IO. And as was mentioned, framework I also consider, because it is this thing that we don't have direct control over. And often it hides a dependency on IO, which is often the problem with it, or it's a life cycle problem where it's controlling, especially if it's a framework. So what I want is a way of thinking about architecture, way of thinking about how do I organize my code. And so I came up with this acronym, and because you have to come up with an acronym these days in order to sell stuff, whether it's ideological or not. And it's Scion-T. So basically, I care about separating concerns of IO and non-IO for testability. Right? So separation of concerns between IO and non-IO. Those are the two kinds of things I care about. Is it IO code? Then I'm going to have to do some different ways of thinking about testing it. Or is it non-IO code, which means it's all in memory. It's all basically running on the CPU or multiple CPUs and in memory in a single process. So I consider IO to be basically anything that is outside of the current process. And so that includes all of these things: hardware, right? Whether it's a system clock, what time is it? What day is it? A random number generator, files on the local file system, remote services, however you were accessing them, databases, including an in-memory database, right? So I see, and I used to do this myself. I'd run a test and I'd run an in-memory database because it's quote fast, and it's really not that fast. When you're talking about wanting all your tests to run in 3 seconds, hundreds and hundreds of tests, if not thousands of tests to run in 3 seconds, an in-memory database is still too slow. And any other processes, and like I mentioned, frameworks. And so why do tests care, and why do I care about tests that have dependencies on IO? Because if they do, then I don't get what I want, which is this: speed, ease, both of running and writing, and predictability. I want speed. I do TDD, or I write lots of tests. I want them to run fast, and I want them to be easy to write, easy to read, easy to run, and I want them to be predictable. So that means, again, there's two kinds of tests. There's IO tests that are going to be slower, harder to work with, and I want to minimize those as much as possible. Like, I want just 10% of my tests to be like that, maybe 20, depending on if there's a lot of integration and interaction with other things. And then there's the IO-free tests. And what I like about IO-free, I say non-IO, but I like IO-free because these tests are practically free to run. So when I'm doing coding in Java and I run my tests, most of the time is spent on compiling and starting the JVM. Running the actual tests is the overhead of those should be almost no additional time. All right, so when I'm working on a project that we'll look at called Ensembler, there are hundreds of tests, but most of the time is spent when I'm running those IO-free tests. Most of the time is spent on running, getting that JVM warmed up. So the separation of concern for testability architectures, there are actually lots of different varieties of them. If you look at it from this point of view of that, really the separation of concerns of IO and non-IO for testability, we've got a bunch. We've got the clean architecture, we've got onion architecture. James Shore has his A-frame architecture. James and I have been doing Monday streams. We've now done 11 of them. We've been talking about differences in designs with his nullable wrappers and A-frame architecture. For those of you who've been around for a while, you may remember boundary controller entity. Same idea as separating some of these, a clear separation between the outside world and the core of your code. And of course, hexagonal. I had come across hexagonal way back when Alistair Coburn first wrote about it. And so it probably stuck in the back of my head and didn't really think much of it for probably around 10 years. But as I really started thinking about how do I make my code more testable, and focusing on and reflecting on what's in my way, and it's that IO. And so having that clear separation between them is what really helped me figure out, oh, okay, I need to do this. And then there's a further refinements that I'll talk about. So when I talk about architecture, I'm talking about the organization of code. How do we organize our code? And how do we organize it so that it's testable and we know where things go? So again, I like prescriptive. I like more structure. James Shirk sometimes refers to as bureaucracy. And bureaucracy isn't always bad, right? If you have a tiny team and they're all experts, like I said, then you can get away with a lot less sort of ceremony and formality. But if you've got larger teams and you're trying to all head in the same direction and think about the same thing, then having a bit more bureaucracies is actually, I think, helpful. But there's a range of it, and you can sort of choose what you want. And I've chosen hexagonal. There's also deployment and operational, but we're really concerned with layers. So layers versus tiers. And I know a lot of people get those two terms confused. But we're going to talk about layers. And so what are layers? They're ways of separating things. But if you look at it from an IO, non-IO point of view, an IO versus an IO free, then it becomes really clear what these layers are about. They're separating out what we care about, which is this middle part, right? The business layer, right? Our rules, our processes, our guidelines, our constraints, all that kind of thing. That's what people are paying for. They're not paying for a presentation layer by itself, right? There has to be something underneath. And these are all, you could come up with 3 layers, you can come up with 5 layers, you can come up with 25 layers. There's a certain point where that's not really helpful, but we care about the domain, right? So what I like about hexagonal architecture is it lends itself towards a domain-centric way of organizing and thinking about your code. And I could talk all day about domain-driven design. I love it. I've known Eric Evans since he wrote the book, and that's something what's really nice is seeing how domain-driven design, which happened sort of around the same time as hexagonal, how they fit really nicely together. All right, so I picked hexagonal architecture sort of, again, after the fact, right? I really focused on how do I make my code easier to test? And I said separation concerns. And okay, how do I separate concerns? And so was reminded of hexagonal. And so hexagonal architecture, as you can guess, well, it gets its name from the shape used in the diagramming, right? Hexagon. Hexagons are the bestagons, as the saying goes. And hexagons have 6 sides. And the history of the hexagon, you can go look at Alistair Coburn's write-up. Basically, he wanted something to sort of break up this idea of rectangles and the idea of there sort of only being a top and a bottom. He wanted something where there's this idea of a center and focus something on the inside and on the outside. And he wanted to have some sort of facets that he could plug some things into. But the number of sides is not important. Right. It happens to be the shape has 6 sides, but the number of sides isn't important. I like the fact that it's a hexagon and not a circle, because we'll see these things that we plug into these facets, these faces of the hexagon, I think is really valuable. So after I'd gotten back into hexagonal and started playing with it, I went back to read the original pattern that Alistair Coburn wrote, which is, he wrote it up as a short pattern, right? The one thing that I need to say, and I'll caveat this now, is the way I interpret hexagonal is not the way a lot of people do it. In fact, I think most people interpret it in a way that is perhaps close to the original definition, but from a testability standpoint is not necessarily helpful. And I'll talk about that when we get to that. And it has to do with sort of the inbound or primary adapters and ports. If you know what that is, then you know that I don't use those. If you don't know what that is, then you'll find out soon enough. But I wanted to show you this quote and have you read this for a second. So I want to highlight two things. One is that it allows the thing to be equally driven. There is no difference to your core code, whether it is a test executing against it, an actor, user, external system running against it, right? Exactly the same. That code should know no different. And that it's tested in isolation from runtime devices, because those are the things, right? Isolation from your IO, because those are the things that make life difficult. It's not that you're never going to write IO, otherwise it's pointless. But the idea is to really minimize the code that touches the IO, and that everything else is sort of this IO free code that is untainted by IO, and therefore is easy to manipulate and work with. Side note, there's two orientations you can have for hexagons, flat top and pointy top. I'm a pointy top kind of guy because I like how if you split it in half, you've got a nice set of three faces on each side that are great for diagramming. But the important part is that there's an inside and an outside. The inside is our application and domain code. And you can either just treat this as sort of a black box and put all your code in here and not worry about any way of differentiating it. Or you can say, I like layers, and I'm going to split this between domain code, pure domain code, right? The business logic, our domain logic, our game logic, that's our domain, and application. I'll talk about a little bit about what those are. But basically, this is the stuff that is providing the value, solving the problem that we are supposed to solve. And then there's the rest of the world that we have to connect to. We get information from the rest of the world, but we also, stuff happens to the code because of the outside world. So what I like about hexagonal, and I don't see this in some of the other sort of ways of thinking about this, is this left to right symmetry. So on the left side, that's where we have external inputs. What causes our application to code to do anything? It's a trigger. Some message comes in, some HTTP message comes in, a console command, whatever it is, something had to trigger stuff to happen. If we don't get anything in, nothing happens. But when we get stuff in, that happens. So there are inputs, there are requests, and then there's data access, right? Because often we need to access information in order to fulfill these requests. Maybe we have it in memory, but we can't trust that, right? Memory doesn't live forever. So we have to often, at a minimum, have persistence, right? Some kind of database, some kind of more durable way of storing information. But also there's information that we might need from other services to fulfill the function, right? What movie seats are available? Do we have stock of this item? How much are shipping charges for this? Whatever it is, we may need to consult with other services, and those are outbound requests. And they may be also events that we have to tell people that something happened. So if you're using an event-driven architecture, you may send out an event saying, hey, somebody bought this ticket, somebody purchased this item, and then whoever cares about it can listen and act on it. So there are many different terms for the two kinds of, sort of the two sides, the left side and the right side of the hexagon. Alistair Coburn likes primary and secondary, or driving and driven. I happen to like inbound for things that trigger work to happen. So an inbound event happens, hits our application domain code, we do stuff, maybe we also make some outbound requests, and then we send that information, the results, the outcomes, we send those out. So we've got inbound that trigger things. We might send a response to the inbound, but the initiator was this inbound message. Whereas the right side is, we are initiating that communication because we needed something, because we got triggered, we got to go trigger somebody else. So let's look at a diagram of hexagonal architecture, so we can see all the parts, and then we'll dive into the details. So we've got our domain, and so I like to have a separate domain, and this domain has no awareness of IO. It's not that it has maybe abstract references or concepts of it. It actually literally has no idea that IO, that the outside world even exists. This is sort of the pure domain, pure conceptual domain. And this is where we put all our code, and we can easily drive this and test this, because we just instantiate objects, call methods, and then verify. Very easy. Even if there are multiple objects involved, what we sometimes call sociable tests, they're still really easy to write and easy to run. In hexagonal, or in any kind of layered system, and hexagonal is a layered system. It's just some of those layers are broken up, as we'll see. We have an application layer, and this is the one that has awareness of I/O, at a minimum, how to load those domain objects into memory so we can do operations on them, and then how to save them if their state has changed. But they don't have a concrete reference. They don't directly access hardware. They have perhaps an interface of some sort, right? So conceptually, they're aware of it, and they're more coordinated. So the application layers load some data in, execute some operations, save it out, and then go send information to some other system. Maybe I had to go fetch some information, then send the results to something else, right? It's more of an orchestrator. But the rules of the domain, those are in the domain layer. And so the way it interacts with those external I/O pieces is through ports. So these things in pink here, persistence, notifier, those are ports. Those are abstractions over the concrete, whatever the concrete implementation might be. And those are part of the application layer. So this is the hexagon. This is our application boundary, what Alistair Coburn also refers to the use case boundary. And this is where we think and understand and talk about what do we want it to do. So we might have a user interface that talks to it, right? So a browser-based interface, or maybe renaissance of desktop apps will happen, who knows? These are the things that we show some information, somebody initiates some requests, and that calls something against the application layer, and then it figures out what to do. Might be in something that comes in from an external message bus or message queue, that some operation has to take place. But we can drive that behavior, we can drive the application layer behavior using tests and using IO-free tests. Because there's no difference. The application layer, everything inside the hexagon has no idea who's driving it. We can plug in tests, we can plug in adapters. And that's what these things are. These are adapters, and I'll talk more about those in a second. So these are our inbound adapters. Then we have our outbound adapters. So we've got persistence, right? Storing our information in a database and allowing us to retrieve it later. And a notifier, so we might have to send out events, and so we want to be able to notify external systems, maybe send a text message, maybe send some other kind of message. From a dependency standpoint, the dependencies flow inwards. Whereas in like a different way of the typical top to bottom vertically layered, we might think about they go top to bottom. Here they go inward. So the innermost piece, our domain, does not have dependencies on anything outside of it. And that's how it can be pure. It can be IO free, completely ignorant about any kind of IO. And so this is our system boundary. It includes all these pieces. And so if you look at this, if you sort of tilt your head or sort of look at it from a certain point of view, right? If you sort of tilt your head, depending on which way you're looking at it, this is a layer, right? User interface goes to the application layer, deals with the domain, talks to some abstraction of our infrastructure, and then talks to the concrete persistence. But note that there's one of the layers is separated from other parts of that layer. So user interface is separated from the external message bus. Persistence is separated from the notifier. And that's very explicit that the parts outside the hexagon are sort of broken up into pieces that are specific to what their task is. And that makes it easy to sort of plug in new ones to test these things. And no domain objects exist outside the boundary. So domain objects are something that run in memory, but as they're persisted, there's no behavior there. It's just state. And I'll talk about persistence later. So dependencies point inwards. Another way of looking at it is there's two kinds of dependencies. there's what I call import and reference dependency. So if we've got a user interface, incoming requests come through it, it has a dependency on the application layer. In order for it to say, hey, a post request came in with some content, we translate that into calling a method on our application layer. Well, we have to have a reference to the application layer in order to do that. That's fine. Direction of dependency is inward. And again, whether it was an adapter for a UI, an HTML UI, or a RESTful API, doesn't matter, because it could also be a test. Doesn't matter. The application layer doesn't know, doesn't care. On the other side, though, because sort of the direction of how things happen, we might want to then store information in our infrastructure. We have to have an implementation dependency. So here we define our port, and this is, you're probably familiar with it, dependency inversion. Now, we don't always have to do dependency inversion. Again, I'll sort of refer to nullable infrastructure wrappers by James Shore, that you don't have to do it this way. I like to do it this way because I'm a Java guy and we like at least some amount of interfaces. And dependency inversion, I tend to work in systems that are already doing dependency injection, like Spring Boot. So I'm going to basically adapt to that. But if you're working in a framework that doesn't have that, there are different ways that you can go. So a couple of projects that I'm going to pull some diagrams and text and code from. One is Kid Money Manager. This was the first application, production application that I created to manage my son's money, because he's too young to have his own bank account, although he actually just turned 18, so now he can open up his new bank account and he doesn't need it anymore. But this was the first project I developed, and I did it all live coding on Twitch, test-driven development, and learned a lot about sort of the nuances of hexagonal. And so one of the interesting things about this is there's two different UIs. There's two different ways to interact with it. There's a web-based UI, which is more for me to look at and look and sort of see history of transactions. And then there's a text-based UI, which is actually most of the way we use it is we're out and about. I don't have to open up a browser. I don't even on my phone. It's just easier to send a text message. And so from a hexagonal diagram point of view, what we have is our core hexagon. It's got the domain, so things like transaction and profiles and goals for savings. And it's got an application layer. And then it's got a web UI and an SMS text message. And so these are the inbound adapters. These are the ones that translate the outside world, whether it's HTML forms that have a post button on it or a text message that comes in. Those translate and transform that information into calls against the application layer. And then there's an outbound text message notification, so we can actually send out, hey, you've reached your savings goal. Why don't you, now you can go buy whatever you were saving for. And of course, persistence. And so these are outbound adapters. Another project, which is something that I'm still developing, that I use for managing ensemble events. So I run learning ensembles. You might also know it as teaming, software teaming, or mob programming. So this tool is for me and my members to basically self-service. So if they want to sign up for an ensemble, they click a button. I can go create it. And this project has one inbound adapter, which is the web UI, but it has a bunch of outbound adapters. So it's got an emailer, SendGrid is what I use. It's got persistence. I actually use Postgres, and it's got a Zoom scheduler because it automatically schedules the Zoom conferences so that I don't have to do anything, right? So it automates some of this for me. And so each one of those has a port to help us communicate with that. And I'll talk about that in a second. So those are all outbound adapters. So you can have mix and match. So some applications might have multiple inbound adapters, or they might not have one. They might have multiple outbound adapters, possibly half a dozen, or they might only have one or two. So it depends on what assistance they need from other things and what they're serving up to others. So when I'm developing this kind of stuff, I have to think about where am I writing my tests? So my IO-free tests can hit the application layer, right? I can drive the behavior of the system through these tests because the adapters are going to call the same code. They're going to call the same methods. And so this simulates the inbound adapter, which of course requires me to understand what is the inbound adapter going to do, right? And so this is where you can think about behavior-driven development, outside in. So to me, with hexagonal architecture, with its left to right asymmetry, it's really not outside in, it's actually left to right. I start on the left. What do I think the adapter is going to need? And maybe I'll even write some tests against the adapter itself, some IO tests. And then I'll figure out, what does it need? What kinds of things is it going to call in the application layer? And then I'll write tests for that. And so I'm driving these scenarios through the application layer. And then when I figure out, okay, I need some domain classes here, I need to update and add some functionality or modify the domain classes, I'm also going to write some IO free tests at this level. And I'll test drive that, and I'll implement constraints and validation and things like that. And so I'm driving here the domain logic directly because I know what was needed, because I was driving the application. I know what the domain needs. I may not have a separation between the two. So actually my Kid Money Manager doesn't have this clear separation. And so I can drive it as just one big blob. Maybe the behavior is simpler or more procedural. But again, the idea is you're driving it, and anything inside of the hexagon is not IO. All right, so adapters, right? So we've got our domain, we have an application layer, we've got this asymmetry of how code gets executed. And so when we want to write tests, right? So let's say I've figured out I have a form for creating an ensemble. Here's the information it's going to send in. I want to create it. How do I write my test? Well, what do I want? I want to think about my test as like, well, when an ensemble is created, then I should be able to see it in the database. And so from an hexagonal point of view, is I've got my IO free test here. And I've got my outbound adapters, but they're not the real things. They are actually testables. And so some people use the term mocks. I'm a bit pedantic, and I like the term testables because mocks are a specific kind of testable. And so there's several different kinds of testables that work with depending on what we're sort of testing. So in terms of what happens when, and how do these work together? This is a sequence diagram of an activity and sort of how does it hit the different parts of the hexagon. So here we've got an API client, and it's sending in a GET request for, I want to view the balance of this account. So I've got a Spring MVC implementation. And so Spring MVC handles this GET request and basically calls a method called account info and hands me 23 as a string. Well, I need to convert this into a value object. I like my identifiers to be value objects. So I go ahead and create a value object. So this does one thing of validating that string that came in actually is a potentially valid account ID. At least it's a number. And so now I have account ID. And then I can talk to the application layer. So the application layer, remember, is for coordinating with external services usually to load information that then the domain can work with. So here I'm doing a find. Hey, application, can you find this account? It turns around and goes to the repository, the database, and says, hey, give me this. Do you have an account? It's going to instantiate, reconstitute that domain object, right? Its job is to load it into memory and then hand that object back to the application so that it can perform a task on it. In this case, the task is actually just load it so that we can extract the balance. And so the job of the adapter is to translate this information. So it takes the account object and then converts it to a DTO. Because one of the things we don't want to do is we don't want to couple the outside world to our domain objects. The application layer, if you can think of about it also as sort of this protective layer. We don't want our domain objects to leak out to external systems because we don't want to couple to them, because that's bad. Because then you change your domain object and maybe you've inadvertently affected an external system. That would be bad. And so we can convert that to a DTO and send that out and then return that. And so I have this principle of domain objects never leave the adapter. What does leave the adapter are DTOs, data transfer objects. So last thing I want to say is about adapters, and then we'll look at ports, and then we'll dive into some example code, is adapter pre-communication mechanism. So each one is, again, single responsibility for what it, is it communicating with an iPhone? Is it communicating with another service, a message queue? I want an adapter per communication, because it's a translator, and you need different translators for different things in the outside world. So when we are testing an adapter, we're going to need both IO and IO-free tests. So if we look at an inbound web UI, there are actually two parts to it, at least in a Spring Boot example. There's the stuff that has to deal with configuring the framework. Did it call? Does the framework, did I write the mappings correctly, the annotations correctly? Did I configure it correctly so that it calls the methods that I want it to call when a post request comes in? So these are IO tests. So I need to write some of those, and it'll depend on the framework. But then the rest of it, whatever it does, is actually IO free. And so these are the things where, okay, assuming this method is called, did it call the application layer correctly? So I'll sometimes call these wiring tests. Did the controller call the right method in the application layer? Right? If the post said create this ensemble, did it call the right method in the application layer? So let's take a look at some of those tests. So here we've got a test. Sometimes ensembles have to be canceled. And this test is testing against the ensemble service. For better or for worse, I've adopted service as the sort of suffix. I go back and forth about, whether I want a better name for that, but people tend to know service, and I try not to go too far astray because I'm usually doing training and don't want to throw too many new things. And so here I'm testing the cancel operation. Did it cancel it correctly? I need to do some setup, which means I need to set up my test doubles for my outbound adapters, mainly for the repository. I need to have a place where it can retrieve it, but I don't want to use a real thing. So there's an in-memory repository implemented using a fake test double. And I'm using builders to make it more, test data builders to make it more concise to create. And so basically I expect when I call cancel that the ensemble in the repository has been appropriately canceled. Now, what's nice about this kind of test is it's a test against the application layer, right? Basically, am I testing that the code operated correctly? But I can actually substitute. I can take almost exactly the same test, plug in a real repository, and it now the same operations can be checked against a real database. And so you can target the tests at both using test doubles, because I'm focused on does the application do the right thing, and does it work when I plug in a real database? So that's testing directly against the application layer. And here I'm testing against, this is an IO-free test. So even though it is in the adapter package, right? So I organize my code according to packages, according to where they fit in the architecture. This is the admin console, the admin dashboard. It's an inbound web adapter, but this is an IO-free test. I'm testing against code that you might consider to be IO, but there's a lot of code in our adapters that has nothing to do with directly calling IO. So I do my setup, I create an ensemble, I create an in-memory version of the repositories, I have my member service to handle that. And basically I want to see, did I get the correct view? Right, so the way we transform domain objects into something suitable for the outside world is we transform them and translate them. That's the job of the adapter. And here I'm translating, hey, with this ensemble and this member, did I get the correct view? This is not testing through the UI. This is just the content that's going to be shown on the UI. Right, and so you may be familiar with subcutaneous tests. That's kind of what this is doing. It's testing just below the UI, but it's non-IO. There's no template engine, there's no HTML, there's no HTTP involved. It's just testing directly against the class. But it's testing it specifically in the context of this specific adapter, this web UI adapter. So for inbound adapters, this is how it looks. We're generally testing things like, did it do the right thing? Did we configure it? Right, so if you're curious about the configuration test, this is sort of what they look like. It's more like, did it respond to the GET request and give me an OK status? If I submit a form, did I get a redirect? Right, just the bare minimum to know that I've configured this correctly and implemented whatever Spring Boot requires. Everything else is subcutaneous, is right at, and is IO free, and that's what I want. So I want all this stuff to be IO free. So those are our inbound. Our outbound ports are basically interfaces that provide a facade for interacting with the outside world. How do I want to talk to the service? And it's implemented by a concrete outbound adapter. So inbound, there are no ports in the way I do hexagonal. And it's probably 90% of the other folks who do hexagonal, and sometimes I wonder if I should even call it hexagonal, but that aside, there is, some people put a port right here, an inbound port. And I see no point in doing that because when I'm test driving this left to right, I don't need an interface here. I don't need some thing that I'm going to substitute. I can talk directly to the object because the dependencies flow inward. So I follow the direction of dependencies and I don't need an interface here. It just gets in my way. Sometimes I use it, but most of the time, 99% of the time, I just test directly against the application layer because it's IO free and therefore cheap to test against. So if I'm implementing a notifying adapter, right, there are three kinds of outbound adapters. There's notifiers sending out messages, fetchers, which are requesting information from an external service, and then repositories, which are kind of a combination of both, but special for persistence. What is the ideal interface? How do I want to talk to this external thing? Write a test. If it's notifying, it's outbound only, I don't get any return information, so I need to use a spy, some way of detecting, did the message get sent? And then I implement the concrete thing. And when we define the ports, this is in the language of the domain. So here in my ensembler, I've got a notifier. It's in the application port. So this is the interface. So here we're starting to be aware that there's the external world, but there's no concrete reference to anything IO. And it speaks in the language of the domain. I use a spy to test. So spies are one of the test doubles. They record method calls and reports what happened. Here I have a hand roll spy, and what it does is it's a spy emailer. And I basically say, did the emails get sent to only those who accepted, right? Emails are only sent to accepted members. That's the job of this notifier. And then I can create the concrete adapter. And even in the concrete adapter, there's two pieces, right? The outbound adapter has the same idea. There's core stuff that is done no matter what concrete mailer I'm going to use, whether I'm going to use SendGrid or some other email service. This code is going to be all the same. It's how do I format the email? How do I transform that information to a form for an email? And then how do I send it? And this is the concrete. This is the part that is IO. This is actually IO free. This is the small amount of code that I need to touch IO. So the last one, the last outbound is a repository. I like to think about repositories from the domain-driven design point of view, which is for storing and retrieving aggregates. I'm not going to go into what an aggregate is. That's separate talk. What we're concerned about is storing and retrieving domain objects. But one of those objects is going to be the thing that we're going to have a handle on. So an ensemble, that's our major object, and it has other things like a conference details, a status, member status, and RSVP. So these are two main objects. We have two repositories. And again, we could just store those and retrieve those domain objects directly, but that couples ourselves to the database and sort of poisons our core domain. So we don't want to do that. Instead, what we do is we create a fake, a testable. So we take the snapshots of our data, and then it's just stored in memory. IO free, runs really fast, and is predictable. Then we implement the real one that translates our snapshots of the data into however we're storing it in the database, whether we're writing SQL from scratch or we're using an ORM, whatever it is, that's the job of the adapter. Again, adapting the snapshot of information to the database. So with hexagonal architecture, what I like about it is the focus on the core domain. Domain objects never leave, so we decouple our domain objects, what Eric Evans refers to as anti-corruption layer. We make sure that we have these, I always think of these as buffers, right? That we're translation buffers, that we can make changes in our domain and it doesn't affect anything else unless we want it to. And if somebody else says, hey, I need a different API, we can change that without necessarily forcing us to have to change our domain. Adapters per trigger and a communication mechanism. So I like that these are separate because it helps us keep these small and targeted. Not that you're necessarily going to replace one with the other. That's optionality that you can have. But again, it's trying to keep things small. And that's one of the things I really like about the adapters. And ports for the ideal interface. So you really think about, from the point of view of the consumer, what do I need from this thing? And then all the complexity of having to actually call that thing. Maybe it's 3 calls that you have to make to 3 different services when it's really one conceptual thing. You hide that from your core code. Dependencies point inwards, and so that helps preserve the domain and application code from being sort of infected by IO. And I like to package based on architecture. And if I've got a modular monolith, I love modular monoliths, then each module is going to have sort of this structure inside of it in multiple places. So I know that was a lot, and the code base, as I mentioned, is open source. Ensembler is open source. KidBank is open source. I'm happy to take questions or look at and show more code. There's a lot of good code in Ensembler. I also have, as I mentioned, almost all of the development was done live on my Twitch stream. And so if you want to watch dozens of hours of video, you can watch how I actually do this step by step. But the main idea is this idea of IO versus non-IO. My goal is to have as much as possible to be IO free tests. And I like the organization of hexagonal, both the layering that we can do inside the hexagon and the adapters that are separate from one another on the outside. So if you've got questions, ask them. If you want to see more code pieces, ask away.
Go ahead, Garrick.
So I'm curious, given that you've talked about a lot of your exposure and your past and everything in the Java world, which by the way, I'm a fellow JVM fan. I've spent a lot of time in Spring, and a lot of my hands-on XP work on teams was in doing in Spring Apps, and so gotten a lot of satisfaction about shipping cool software that way. One thing that I'm curious about, and I'll go ahead and let out a little bit of my bias, and I'm curious from what you've heard, if other people have tried or if you've tried. I've been getting my toes into the hellscape that is what people call front-end development, either with Angular or with React. Unfortunately, it seems React is becoming more popular, but that seems, as I've been slowly learning, to have less rules and guard rules pushing towards better architecture. I'm wondering, have you seen people coming along and saying, gee, that's a nice framework you have here. How about putting something like what you're proposing to make it testable? Are there examples you've seen out there in the wild of people saying, that's a great blog post in the demo, and you're showing me exactly what not to do in production?
Yes. And so I am a back-end guy, and I cringe at how much. And again, I'm not going to go into my usual rant about single page applications.
SPAs, okay.
but I have opinions. But there are a couple of people. If you hit me up offline, I'll go find. There is a couple of people who do focus on TDDing React, as well as applying hexagonal architecture or similar kind of architecture to React. And I think you can do that. I think it's not easy. You're fighting a little bit against the grain, it feels like. But I think you can, and I have seen some people talk about applying these same principles.
Cool.
It's like, what, so IO is like, if you're talking to a dummy, or even, I don't care if it's a verse, like if you like, there's UI logic, but that is based on state, and I'm going to basically change state and something. And then there's the representation of that on the UI. And I think those should be separate. And there's a couple of folks I'm thinking of think exactly the same way.
Cool. I will definitely hit you up for that. Thank you.
Yeah.
So Ted, in the examples that we've seen, you have hand-rolled your test doubles. Do you have any advice or opinions on hand-rolling test doubles versus relying on a framework?
Yeah, so I will use a tool like Makito for what Jipo Hill calls legacy rescue operations. If I'm like, oh wow, I need to sort of separate myself from this thing, and it's just a ball of mud or something, then I will use a tool. I find though, however, I really recommend against using them, because one of the things I like about hand rolling them is that you feel some pain. So for example, here in the notifier interface, this is actually a little painful to test double, because there are 3 methods. And it means every implementation, I've got a dummy, I've got a spy, right? I've got to basically implement stuff that I actually don't care about for a test. So I have to throw this unsupported operation exception, because the test that I'm using this spy with only cares about member accepted, this method over here. The other 2 that are part of the interface, the part of the port interface, I don't care about. To me, this is a smell. This is saying, I think your interface is too wide, it's too big. And I want people to feel that pain, because it helps improve their design sense of, oh, well, okay, maybe this is too big. Is this really, do I really need to group all these things together? Does that make sense? Sometimes it does, but I want them to be thoughtful about that. And so that's really why I try to have people, especially when they're learning this stuff, really avoid using some kind of mocking tool. Is I want them to be thoughtful about what they're actually mocking. What are they actually replacing with? Plus, I've also seen far too much code. I'm sure we've all seen a lot of code where it's like, what are you actually testing here? Where it's mock setup, do something, mock, and it's like, I don't know what you're actually setting up. I don't know what you're actually testing against. And again, a lot of them I see where they're mocking out what would in hexagonal be the application and domain layer. It's like, why do that? Why add something when though, in fact, using a mocking tool like Mockito is actually slower than using the raw objects. And the raw objects are cheap, right? The application and domain objects are cheap because they're IO free. And so they're actually cheaper to use those and instantiate those than to use Mockito, which has to do all this fun work. And so ironically, the mocking library can actually slow your tests down.
Excellent, thank you.
Hey Ted, this is Trent. I've actually been really excited to be able to attend this because I've actually been trying to get into Hexagonal myself. I'm actually coming from the PHP side, and I actually learned about it through some folks that help maintain the Laravel ecosystem. So Laravel, there's a Laravel Beyond CRUD book series. The one thing I'm just kind of solidifying what you're saying, where when you think about breaking these tests out in the way that you presented them, especially with setting up your own like harness here, basically, that is one of the best ways to find, oh wow, I really am doing way too much with this test. I have to set up way too many objects. I have too much being done in this one class or one function. So not really a question, it's just more of a confirmation. That's one of the reasons why I also agree with the idea behind hexagonal and domain driven. It's like taking what are you trying to do, simplify it down to the most important part of what you're trying to do, write your test according to that, and don't have to worry too much about all this other stuff that could go wrong. Because as long as you have the right approach to handling it, then you could be any error that happens. As long as you respect that any error can happen, your code is going to be, your design is going to be way better, way more reliable, way more predictable, less chance of your system getting into an unexpected state. So just kind of confirming your points, really.
Yeah, thanks. Thanks for selling people on it. Yeah, and so one of the things that happens is as you write tests that are further out, you end up having to do more setup because you have to instantiate some test doubles, and that's where. So, for example, in some of these tests, like let's go here. So there's a fair amount of setup, but it's and this is where you slowly try to build up test data builders and different ways of doing that. And then and there's another step that I could take with some of these. You never have infinite time, so there's some refactoring that certainly I could do here to make them even less sort of ceremony. But the idea, is exactly that. It's like, I like having a bit more structure and a bit more. Where does this code go? Is a question that's like, where does this thing go? It's like, well, are you transforming data from the outside world to domain or vice versa? Yes, it's an adapter. Are you writing code that's a rule about how this discount should be applied? That's domain. Are you writing something where I'm fetching information to find out what the shipping charges are so I can hand it into somewhere? That's in the application layer. And so for me, I and the people I work with to teach this stuff, it really makes it clear. And I having that structure, I really like, and it doesn't work for everybody. And that's why I always talk about really the primary thing, like the thing that I hope that people get out of a talk like this or my courses is like IO and IO free, keep them separated, and testing will be much easier.
Yeah, I just want to add, I think it's also usable in the legacy or large system context, right? So it's just trying to find those seams to be able to put something that you can, strip out IO, strip out dependencies, make sense of it, a little island of sanity.
Yeah.
And then
yes, that idea of I'm growing this island of sanity. I love that. Yeah.
I think also you had the earlier question about what makes testing hard. I think it's like the nuance of what to test and what not to test, and I think this really helps a lot with that as well. Just having that picture and then using that picture to drive. What are the areas that I need to focus on?
Yeah, that's why I always refer to how I do software development as left to right development, because it's left what does the adapter need? I may or may not implement all of the adapter, but I want to figure out what does it need from the application. And then I start writing tests, and then writing tests and refactor and writing tests. Oh, okay, I need to store this somewhere. Okay, fill that in and slowly grow it out. Yeah, so outside in is like outside in, but because of the left-right symmetry of hexagonal, right, inbound on the left. So I start from there, and then I figure out what do I need my application to do, and oh, it needs to consult some stuff on the other side. So it's outside in, but it's left to right, because that's how I start with a fake and I implement a whole bunch of code, not even having a real database yet. I can actually play with the application, and then okay, now I need to store it because now my domain is more stable, so I can now commit to a schema for the database and then start writing that and test drive that. And it works, when I've on this project, the ensembler, there have been basically no bugs, and it's been running in production. And yes, a lot of that's TDD, but really organizing it and thinking about the development in that left to right.
One other thing I kind of wanted to touch back on, maybe quickly, when you said a lot of people with hexagonal architecture refer to the input as a port. I've tried to phrase that myself, and maybe this lines up with what you were saying, as that's actually an application. So the web UI is an application. If you have an administrative UI that a specific set of users uses, it's not the same as the customer facing, for example. That's a separate application in your application layer.
Mm-hmm.
If you have a console command, a console interface to fire off like background jobs or anything, that's another application. If you have events that are being received, that's another application. So like they're all individual independent applications, and you keep them separate so that you don't cross concerns between your user base and the input method. You keep them completely separate from one another.
Yeah, and so this is, I think I might have skipped over this. Adapters can't depend on other adapters.
Right.
And enforcing that makes it really clear that you have, if you change one API, you don't unintentionally have now changed 3 others, right? That you keep them independent from each other as well. Yeah. I think Garrick, did you have a question?
Yeah, actually, kind of a comment, and kind of a I thought it was a small point, but it was a kudos. That's a brilliant example, and sometimes I feel like we don't see enough of it. When you had your example up, when you showed the sequence diagram, and you had that magical word of account ID, the number of times we leak things across the domain, the abstractions. We leak abstractions and we say, oh, an account ID. Well, we know that's going to be this ID in the database, so that's just going to be, well, we'll just use a long for now.
Right.
And ultimately, the sad thing is that the correct answer, no, if you pull back to your good OO design, is no. Even if that is the way it's stored for now, just assume that you still have an account ID, because if something comes along and the application blows up, and the sales guys are saying, hey, we're getting billions of licenses for this or whatever, you go, oh my God, that long isn't going to work anymore. I need a GUID. And then all of a sudden you're plumbing all through your application to change that long to a string that you have to check as a GUID. And it's like, no, if you'd had that class as application ID from day one, you could have isolated that concern. So that made me happy to see. I thought that was a great part of your example.
Yeah, actually, I learned that a while back from Vernon's book on implementing hexagonal architecture. And at first, I'm like, "What? I don't understand that." And then it took me a while to understand that. And now, yeah, you're exactly right. And leaking how that should be completely opaque. Like maybe the database is using a long, but the outside world, I actually don't want to expose even that there is a long. I might need to translate it to some other identifier. So there's sort of the public identifier versus sort of the private identifier. And I think encapsulating that concept into a class to me is just, for me, sort of natural good OO. So thanks for pointing that out.
Well, in some cases, those for fun, those can also be security issues. I'm sure people remember when the pandemic came out and everyone started using Zoom. And then there were problems with people just randomly guessing meeting numbers and parts and submitting them.
Well, I should kind of add on to that. It's not necessarily just the type. but it's also where is that ID might be generated from. So if you change the source of truth for that ID, you change, you may change the value type, but you also may change the source of wow, I'm sorry, I'm having trouble coming up with the word, but basically, where does this ID get created or generated from?
Yeah,
So,
it could be the database is generating from some sequence, or it could be an external concrete generator. And in fact, those would be if it's a standalone thing, that would be another outbound adapter, even though it's getting a tiny bit of new information. Give me an ID that's unique. Give me a UUID, because that involves hardware and random numbers and MAC addresses and all that kind of stuff. That's actually something from a testing standpoint, you want that to be predictable, but then at runtime, you use the real, hopefully unpredictable or semi-predictable kind of thing. Yeah. So as I mentioned in the beginning, just the 5-second ad, if you visit R2HA, which is stands for Refactoring to Hexagonal Architecture, I have an entire course on refactoring to hexagonal architecture where we dive in deep on this stuff. So if you go there now, you can sign up for the waiting list. Sales will reopen for a few days, and you'll get a chance to get access to that.
This is great, Ted. Thank you. Are these slides available on your website?
I will put up these slides on the website. So if you visit ted.dev, because this after all was a TED talk, then I'll make the slides available. And I have a Discord community where we talk about this stuff. Lots of great conversation about that, totally free. So if you go to ted.dev/discord, you'll see information for that. And
excellent. And
I'll post to dive into that
in the comments for this talk. I'll post the link to your website so people can find it.
Good job on getting TED.dev before the TED Talk company did.
I was actually amazed that I was able to get it, so I'm very proud of it.
Yeah, I always saw that. I'm like, is that just TED Talk? No, that's actually his website.
Yeah, it's me.
Awesome. Well, thank you, Ted.
All right, thank you.
Just hitting time now, so thanks everyone for joining us. Really appreciate you being here, Ted, and for everybody else, feel free to come back for future meetings.
Thanks, everyone.
All right, take care.
Bye-bye.